In this video, we're going to take a look at the remainder theorem, what it is, and then why you use it, sort of thing. We'll do just one example because it's pretty straightforward. Alright, so the remainder theorem says that if a polynomial f of x is divided by x minus c, then the remainder is f of c. So I can just take my c value, plug it into my function, and that's going to give me the remainder. That way I don't have to do long division with my polynomial. I can come up with that remainder very, very quickly. Okay, so you might encounter a question that just says find the remainder using the remainder theorem if we've got the polynomial x to the third minus 3x squared plus x minus 5 is divided by the binomial x minus 3. Alright, now applying this remainder theorem, then I could take, if this was called f of x, if this was my f of x function, alright, then I could take the opposite of what I see here, because this is x minus c in my formula, which means then I'm going to pull out the opposite of what I see. So I see a minus 3 there, so I'm going to plug in a 3. We're going to assume that this function is my f of x function. Alright, so then I'm going to test f of 3. Alright, and this is going to be a lot faster than attempting to do long division on this polynomial. So in other words, I'd have 3 squared minus 3 times, or 3 to the third, sorry, minus 3 times 3 squared plus a 3 minus a 5. Doing that arithmetic really simply here, we've got a 27 minus a 27 plus a 3 minus a 5. So those two 27s are going to cross out, and that's going to leave us with a negative 2. Alright, so by doing that, just that quick, no long division, no nothing, I would know now that the remainder of this is a negative 2. So we could write that. Therefore, negative 2 is the remainder. Okay, now to begin with here, just to verify that that really does work, because it doesn't necessarily seem like it's going to, alright, you might want to do a check, alright. The whole point of this is to do it faster so that you don't have to do long division, or you don't have to do anything of that nature. You can get the answer really quick. But if I was going to check, I probably wouldn't choose to do long division. I would probably choose to do synthetic division. So again, I would take the opposite of what I see right here, and I'd put it in my little box for synthetic division. I would go and I would take all of my coefficients, so a 1, a negative 3, a 1, and a negative 5. I would bring that 1 down. 1 times 3 is 3, and then we always add going down, so that's going to give me a 0. 0 times 3 gives me a 0. 1 plus 0 is going to give me a 1. 1 times 3 is going to give me a 3, and then when I add going down, I'm going to get a negative 2. Alright, which is exactly what we said the remainder was going to be. With synthetic division, that went pretty good. If you tried to do that with long division, it would take a little bit more effort. But basically, the remainder theorem is just going to help you find that remainder really easily by just plugging it into the function. Definitely thanks for watching, and don't forget to subscribe to the channel. Thanks.